In the previous session, we understood about basics of electronics, how to manufacture, how to obtain p-type semiconductor and n-type semiconductors. Okay, now here silicon is pure semiconductor, right? Silicon is pure semiconductor. When we add trivalent material, we will get p-type semiconductor. We will get p-type semiconductor. When we add pentavalent, we are going to obtain n-type semiconductor. P-type semiconductor and n-type semiconductors. Okay. Now the purest form of semiconductor. Silicon is a pure semiconductor, means it is in purest form. The purest form of semiconductor, these conductors are called as intrinsic semiconductors. Purest form of semiconductors are called as intrinsic semiconductor. That's it. So when we add, so p-type means I already told trivalent plus silicon. P-type means pentavalent plus silicon. So penta plus silicon. Okay. So these two types of semiconductors, new semiconductors, are called as extrinsic semiconductors. Extrinsic semiconductors. Extrinsic semiconductors. Intrinsic semiconductors and extrinsic semiconductors. Okay. Means extrinsic semiconductors are not pure semiconductor, means impure form of semiconductor. Impure form of semiconductor. Intrinsic semiconductors are nothing but pure form, purest form. Pure form of semiconductors are called as intrinsic. Impure form of semiconductors are called as simply extrinsic. So simply examples for intrinsic semiconductors are simply silicon, germanium, etc. Purest form, not bonded with anything, not doped. Semiconductors which are not doped, those are considered as intrinsic semiconductors. Next, which are doped? Semiconductors which are doped, those are called as extrinsic semiconductors. Means which one will have more electrical conducting properties? These extrinsic semiconductor will have more electrical conducting properties or more electrical properties or electrical conducting properties. Electrical conducting properties. When compared to extrinsic, intrinsic doesn't have that much level. They cannot even be used as an electronic device in electrical circuit. Means they can't contribute electricity, very less in number. Therefore, extrinsic semiconductors are used in electrical circuits, electrical power systems, or in any electronic circuit. So which semiconductors are used? Extrinsic semiconductors are used. So that's the information related to intrinsic semiconductor and extrinsic semiconductors. Okay, now we will understand about diode. How diode is formed. Through that we will understand the nature of power diode. Then by that we will start our SCR, means SCR family means Thyristor, which is part of the SCR family. Now I am explaining here how diode is formed. It looks like very simple thing, but it is very important one to understand any electronic device. To understand any electronic device, whatever electronic device it may be, transistor, diode, transistor, BJTs, MOSFETs, anything, thyristors, UJTs, whatever it may be. Okay, power MOSFETs, power BJTs. Understanding diode is important. Okay. Generally, we will learn the definition of diode as combination of p-type and n-type will give diode. But we will make some changes for understanding in very clear manner. Okay. Now, how a diode is formed? We will understand by diffusion process. How a diode is formed based upon diffusion. Okay. Now, first of all, we need to take a silicon layer like this. A silicon layer, I am considering a silicon layer like this is silicon layer. I am writing here this as silicon. So just for draw an imaginary line here, we are partitioning this part, this silicon layer into two parts. Means consider a silicon layer like this and consider don't make partitions, means just assume this side as half or one half, this side another half. An imaginary line is separating. Okay, now what we need to do? In this left half, we need to send trivalent material. We need to bond this material, this section with trivalent materials. So if we bond with trivalent material, which material we will get? P-type. That's it, very simple. P-type means which are majority charge carriers? Holes are majority charge carriers. Holes are majority charge carriers. Holes are majority charge carriers. Which are minority charge carriers? Electrons are minority charge carriers. We already understood. So somewhere I am showing here 4 electrons here like that. Minority charge carriers. Only half only. Only left half we are sending trivalent gas. So the silicon is combined with will make silicon atoms will take the electrons and bonding occurs. Thus leads to the p-type material. So this is p-type. Half section is p-type material. Half part is p section. On the right side, right half, we need to send pentavalent gas. If you send pentavalent gas, which are majority charge carriers, already we understood in the previous sessions. Electrons are the majority charge carriers. Okay. Now, which are minority charge carriers? Holes are minority charge carriers. For a while, I am showing only 4 holes here. For understanding sake. Like this. This is the story of a diode basically. In this manner, diode is found. Basically, diffusion process. When you take silicon layer, on one half we need to send trivalent, we need to bond with trivalent. On another half we need to bond the silicon layer with silicon atoms will be bonded with pentavalent materials, pentavalent atoms. So p-type and n-type is formed. Thus it is called as p-type, combination of p-type and n-type, but it is formed on single layer only. Thus a diode is formed. Now observe the things very carefully. You need to pay more attention now onwards. So we know, let us take a north pole and south pole, a magnet like this. Let us take a magnet like this, north pole and south pole, a small magnet, north pole and south pole. Another magnet you take, north pole and south pole like this. I am placing here south pole on left side here. Okay, I am placing south pole on left here like this. South pole are brought near to each other. Means similar poles repel each other. We know that one. And dissimilar poles attract each other. Similarly, positive will repel positive, negative charge will repel negative charge, positive charge will attracted towards negative charge. So I am writing here repelling nature, here repels, here which force will exist? Attractive force. Attractive force will exist. So positive repels positive, negative repels negative, positive attracts negative or negative attracts positive. Dissimilar charges will attract. Now observe the things carefully. This is the partitioning layer, partitioning line, imaginary line. We are not cutting into two parts, an imaginary line. So on left side what we are having? Holes are, we have holes. Holes are means which charged particles we need to assume it as them as positive charged particles. So there is repulsion between positive charge and positive charge. Some holes will be sent towards left side. So these holes are shifted towards left side like this. Holes are shifted towards left side. They cross the boundary. Like this. So for a while I am removing these minority charge carriers for understanding sake. I expect you copied the story. Okay. So here also I am removing some electrons. So here on the right side I am showing the concentration of electrons here, more number of electrons, because this is n side. Okay, like that. So some holes are shifted towards n side. So I forgotten here to write n here, n side. This is n side. Okay. So these holes are shifted towards right side. Why? How? Due to the repulsive force. Due to the repulsion force. Similarly on right side, we do have so many electrons. So electrons will repel electrons. There is a force between repulsive force between electrons and electrons here. So some electrons will cross the boundary. Some electrons will cross the boundary like this. So for a while I am removing these holes also. I expect you copied. So I am showing holes here. Now some electrons will be shifted towards this side. On p side some electrons will present like this. For a while I am showing here more electrons here for understanding sake. On right side I am showing more holes here for understanding sake here. Like this. So actual p type is this section. Actually p type is from this line to this end. Actual n type is from this line to this end. But now what happened, due to the repulsive forces, some holes will be shifted will move towards n type and they settle there. Some electrons will move towards p side and they settle here. Settlement means rather due to the strength of the repulsive force they move this side, rather than repulsive force will not be greater, therefore they will settle here. Right? I hope it is clear how this layer is formed. Now I am drawing another imaginary two imaginary lines like this. Okay, another two imaginary lines. So here which nature is formed beyond this one? Positive nature is formed, because holes here negative nature is formed. Okay, negative nature is formed. Like that, a junction is formed. Observe the things very carefully, because this junction plays major role in thyristors. Okay, concentrate here. So a junction is formed like this in a p-n layer. In a p-n layer section, a junction is formed like this. Everything here is positive, everything here is negative. Okay, therefore I hope it is clear to everyone who are listening. Therefore a junction is formed. So I am writing here P and here I am writing N. Now what happens? Observe the things carefully. I am using the same figure for explanation. I expect you are copying in the notes. So I am using the same figure. Okay, fine. Now I am connecting a positive polarity to p type and negative polarity to n type. Suppose positive polarity to p type and negative polarity to n type, like this. Okay, positive polarity to p, negative polarity to n. Already we observed negative repels negative, positive repels positive. So since I connected electrons, means n type to negative, so there is repulsive force between. Repulsive force is provided by the source negative. Source negative repels the electrons. Okay, so due to that repulsive force, these electrons will try to move from n side. This is n side, this is p side, right? This is p and this is n. Okay, due to this repulsive force, the electrons will try to move towards p type, because if we are applying some repulsive force, where they can move, not this side, they cannot come this side, they need to move this side, opposite to that one. So electrons will try to move this side, but what they observe when they want to try to move this side, already electrons are there. These electrons will show repulsion. These electrons also show repulsive force. Therefore, these electrons will repel upcoming electrons. Once again, I am repeating. Due to whenever we apply the supply, this negative terminal will apply the repulsive force on electrons. So electrons will try to move towards this side because they cannot move towards this side because repulsive force. Due to repulsive force, they will move in this direction. So electrons will try to move like this. But already what we are having at the junction on the p side, electrons are there. These electrons will not allow the electrons, incoming electrons, to move this side. Now what we need to do? We need to increase the repulsive force. We need to increase the repulsive force, right? Otherwise electrons cannot move, current cannot be produced. So if we increase the repulsive force little bit, the repulsive force will be increased, but still some electrons, these repulsive force will be high sometime. Up to some time, these electrons will not allow these electrons to come towards B side. So we need to increase little bit. Then if we increase the repulsive force, electrons will try to move this side. So as we increase the repulsive force on N side, the repulsive force offered by these electrons which are already on P side will be less. Means repulsive force due to these electrons will be less when compared to the repulsive force provided by the supply on these electrons. So repulsive force will be more here, repulsive force will be less. Therefore these electrons overcome the repulsive force offered by these electrons. So therefore the electrons will move like this, in this direction, that is nothing but this process of overcoming the repulsive force. This process of overcoming the repulsive forces offered by the electrons on opposite side, nothing but p side, is called as junction breakage. Simply, whatever the electrons on p side, whenever we apply some source, whenever we connect a source, the source negative terminal will apply some repulsive force on the electrons. These electrons will try to move towards p side, but already some electrons are on the p side. Therefore electrons will repel. So this electron will apply some repulsive force on the electrons coming from the n side. So we need to increase the repulsive force such that the repulsive force is greater than the repulsive force offered by the electrons on p side. Therefore when we increase the repulsive force, means increase the supply voltage. Simply repulsive force means if we increase the supply voltage, repulsive force will be increased. Therefore the electrons will move, overcome the repulsion force offered by the electrons on p side. Therefore electrons will flow easily. That is the meaning of junction breakage. Similar thing will happen on the p side. So if you apply some plus voltage to holes, these holes will try to move towards n side, but already due to the presence of holes they cannot move. So if we increase the supply voltage, therefore these holes will experience more repulsive force from the source. Therefore they will move like this. Whatever the repulsive force created by the source on these holes is more than the repulsion force or repulsive force offered by these electrons on n side on the incoming holes. Therefore holes will move towards n side like this, inside the diode, This is called as junction breakage. Simply flow of electrons through the junction, through the diode, is nothing but junction breakage. If junction is not broken, means the repulsive force, if the electrons cannot overcome the repulsive force offered by the electrons on p side, electrons cannot flow. So if they overcome that repulsive force, electrons will flow. That constitutes the electric current. Then only current flows. So how much is the voltage? Suppose if you apply 0.0 volts, it will not be like this. Okay. So the voltage we need to apply is minimum 0.7 volts. So if you apply 0.1 volt, electrons cannot move. If you apply 0.2 volts, electron cannot move. If you apply 0.6 volts, electron cannot move. So if you apply 0.7 volts, then only electrons will flow. If you apply 0.7 volts, then only electrons will flow. Now I am drawing the graph here, very important graph. You need to understand the graph very clearly. This is voltage axis, This is current axis. So if you apply 0.1 volt, no result. Current cannot flow because junction voltage is more, repulsion force is more. Therefore, junction breakdown voltage is 0.7 volts. Means until and unless we apply 0.7 volts, electrons cannot flow from one place to another place. So 0.1 volts no current, 0.2 volts no current, 0.3 volts no current, 0.4 no current, like that. At which point current will flow? At 0.7 volts only current flows through the diode. This is the forward characteristics of diode. So just show the little bit bent only because heavy current flows after junction breakage. After junction breakage, heavy current flows because there is no opposition. So all the electrons will flow easily. So heavy current flows through the diode. These characteristics are called as forward characteristics of diode. Forward characteristics of diode. Forward characteristics of diode. I hope it is clear to everyone. So what is junction breakdown voltage? This voltage is called as junction breakdown voltage, or simply breakdown voltage. What is the meaning of junction here? I explained everything clearly. Okay, how much voltage we need to apply? Minimum 0.7 volts is need to apply. Suppose if we apply 0.2 volts to the diode, does current flow? No, current cannot flow. Why? I explained everything clearly. So the junction breakdown voltage or junction breakover voltage of diode. Junction breakover voltage. Junction breakover voltage of diode is 0.7 volts. Of diode is 0.7 volts. This is the story of forward characteristics of diode. In the similar manner, we do have forward characteristics of thyristor. In the next session, I want to include some extra concept. Okay, some extra concept I will explain clearly. I want to include some extra concept because due to the presence of minority charge carriers, small current flows through the diode. Okay, what we observed, if you apply 0.1 volts, current cannot flow. If you apply 0.7 volts, current cannot flow, we observed. But actually very minute amount of current in microamperes, nanoamperes current will flow. Why though? Why that current? That current cannot be useful. That is not at all useful. That's why we will consider as zero. But a small current flows due to the minority charge carriers. How the minority charges current flow, we will understand very slowly. That is otherwise called as forward leakage current. That's otherwise called as forward leakage current. We'll understand in the next session.